High on the Giza Plateau, the Great Pyramid stands as a dark silhouette against the star fields of the northern sky, dominating the desert landscape exactly as it has for over 4,000 years. This structure contains approximately 2,100,000 blocks of limestone and granite, some weigh up to 70 tons, stacked with such precision that they reach 140 meters into the air. The scale is so massive that the human mind often struggles to reconcile it with the technology of the Bronze Age, leading many to search for explanations in science fiction or lost high-tech civilizations. The archaeological reality is more complex. The pyramids were the result of a total mastery of two separate dimensions: the physical laws of the earth and the mathematical cycles of the sky. To join us for more deep dives into the engineering of the ancient world, like this video and subscribe to the channel. This is the story of how a human labor force bridged the gap between the heavy weight of desert stone and the perceived perfection of the cosmos. Constructing a monument of this scale required a foundation that was perfectly horizontal. Even a tiny variation at the base would amplify as the layers rose, causing the entire geometry to twist or collapse. This diagram illustrates a primary theory for how they leveled the site. Engineers carved a grid of narrow trenches into the bedrock and filled them with water. Because the surface of a still body of water is always level, they had a natural 360-degree reference line to follow as they chiseled the rock down. They also utilized large wooden A-frames equipped with plumb bobs. By ensuring the weighted string aligned perfectly with the center mark of the frame, surveyors could confirm the flatness of the terrain, inch by inch across the entire footprint. Once the foundation was set, the builders had to solve the problem of moving millions of multi-ton stones from the quarries to the construction site. Without the use of the wheel, they relied on heavy wooden sledges. Physics experiments show that by pouring a specific amount of water onto the sand in front of the sledge, the wet grains create a stiff surface that allows the runners to glide, cutting the required pulling force in half. The ancient environment supported this effort. During the Old Kingdom, a branch of the Nile flowed much closer to Giza, allowing barges to deliver stone within walking distance of the plateau. These methods demonstrate that the project was rooted in a practical, empirical understanding of fluid dynamics, the principles of friction, and heavy ground pressure. As the pyramid grew, the challenge shifted from horizontal transport to vertical lift. A straight ramp long enough to reach the summit at a manageable slope would require more material to build than the pyramid itself. This comparison chart shows why a single, massive external ramp was likely mathematically impossible. This logistical hurdle led architect Jean-Pierre Houdin to propose an internal spiral ramp. In this model, the lower third was built using a short external ramp, while the remaining height was reached through a tunnel spiraling upward behind the outer casing. This theory is supported by micro-density scans of the structure, which reveal a spiral-shaped void of lower-density material following the pyramid's inner perimeter. To achieve the airtight joints seen in the limestone casing, some researchers suggest a chemical solution. Joseph Davidovits posits that the Egyptians used geopolymer chemistry to cast certain blocks in place using liquid limestone cement, allowing them to mold stones that fit together with microscopic precision. This level of stonework suggests a mastery of logistics and material science that allowed for engineering at a scale rarely seen in the modern world. The physical effort of moving these stones was driven by a specific metaphysical goal. The Egyptians designed the pyramid to serve as the gateway for the pharaoh's transition into the afterlife. This spiritual requirement demanded an astronomical alignment. The structure's footprint is aligned with a precision of within 3/60ths of a degree. This is a level of accuracy that is entirely impossible to achieve without meticulously tracking the motion of the stars. To find this line, priests use two simple tools: the Merkhet, an instrument made of palm ribs, and a plumb line carved from hippopotamus ivory. This diagram shows how they bisected the arc of the heavens. By marking the exact spot where a star rose and where it set, and then splitting the difference, the builders could drop a vertical line to the ground that established an absolute north-south axis. This celestial orientation is embedded within the stones. Deep within the core, 4 narrow shafts project outward from the internal chambers. These were not vents for air, but targeted stargates aimed at specific points in the sky. The northern shafts were locked onto the circumpolar stars. These are the stars that never set below the horizon, representing the eternal, unchanging nature of the divine. The southern shafts were aligned with Orion and Sirius, the stars associated with the gods Osiris and Isis, the patrons of death and rebirth. By integrating these stellar coordinates into the architecture, the builders tied the pharaoh's fate to the clockwork of the universe, intending for the pyramid to function as a machine for eternal life. The structural perfection found at Giza arrived only after generations of trial and error. The evolution began with the step pyramid of Djoser, where the architect Imhotep first experimented with stacking stone mastabas to create height. They also faced near disasters, such as the bent pyramid. When the structural load became too heavy for the soft ground, the builders had to abruptly change the slope's angle to prevent the monument from collapsing. The lessons learned from these failures, how to manage ground pressure, how to reduce friction, and how to track the stars, became the foundations of engineering. We still use these same principles in hydraulics and surveying today. The pyramids remain history's most prominent example of the human effort to transcend the physical world. Their massive scale was achieved not by magic, but by the focused application of human intellect and labor. Which part of the pyramid's construction fascinates you the most? Let us know in the comments, and don't forget to like and subscribe for more.